Hello, good morning, everybody, and welcome to this webinar. This is another webinar from Man and Machine on the topic of Fusion and the Fusion extensions. If you've already joined us for our previous couple, this is a follow-on action looking at the 3D printing world. If you haven't already seen the previous ones, they're available on our YouTube channel. Please go and like and subscribe to our YouTube channel. So this topic for me is one that I'm personally very excited about. Now, 3D printing is nothing new. It's been around for a long, long time. A lot of you, I'm sure, already have some form of 3D printing, probably used for prototyping, for testing, for getting a look and feel about what a product looks like. And what we wanted to do today on this webinar was really to explore what Fusion from a software perspective can really do for you if you are 3D printing. We also wanted to explore the additive extension, and I'll explain about what that is and how that fits into the equation and how much further you can go. Now, whether you are just looking at prototyping or whether you are looking at additive manufacturing from a production point of view, it's worth spending the next hour, the next half an hour, 45 minutes investigating this exciting topic. So welcome. Now, we're obviously using Zoom. You should all be used to Zoom these days. I'm sure you've done hundreds of these sort of Zoom webinars, but of course there is a Q&A box at the bottom of your screen. If you have any questions or concerns while we go around the presentation, while Cameron's doing his presentation, please feel free to ask your questions in the Q&A box. We will try and either answer them on Zoom, we have a team of people here to answer your questions, or if we have got time, we'll try and answer some of those questions live at the end. So my name is Simon Brand. I'm the sales manager here for the manufacturing division at Man and Machine. My contact details are on screen, and I'm personally very passionate about manufacturing in the UK and making it as efficient and profitable as it possibly can be. And one of the areas that I see as being particularly of interest for a lot of manufacturing companies these days is the world of additive manufacturing. I went to a facility, I've been to hundreds of manufacturing facilities in my long career, and I've seen a lot of what you guys are doing. And typically when you have CNC, subtractive manufacturing processes, the shop floor is full of huge machines that take up a lot of floor space and need a lot of people to operate. I went to a facility it was actually in Germany near Frankfurt, a few years ago, that was an additive manufacturing facility. And I was shocked by how many machines were in that facility in a relatively small footprint, but I was also really shocked by how many people were operating so many machines. And I really saw it then as an opportunity for manufacturing companies to be as profitable as possible in order to minimize their workforce and maximize their throughput of material and jobs. So Fusion, if you've been on the previous webinars, Fusion is an exciting platform. It's been around for a fair few years now, and the way that I think about Fusion is it is a complete platform of everything from concept to visualization and manufacturing and electrical design, all within one program, allowing you to minimize your workforce, to have one person doing the job that traditionally was done by 3 or 4 people, all in the same program, the same user interface, and that flow of information from start to finish can really be realized with Fusion. As well as that, we have the ability of collaboration. Manufacturing has changed and evolved so much over the last few years. I'm sure a lot of you have been through a huge amount of change, but ultimately we're here to try and reduce cycle times, to try and make parts as quickly as possible, and to get things done quicker at more profit. And that's what Fusion is about. The way that it's packaged is perhaps slightly different to maybe what some of you are used to traditionally. If you think about the traditional design and manufacturing process, you might have to do elements of CAD, elements of CAM and PCB and simulation and visualization. And historically, what you would have to do was to buy, to justify the cost and to train the individual in each of these separate areas. And that could be 5 different people in reality, what we've seen over the years is actually a lot of companies are now trying to streamline things so that the CAD guy is also operating the CAM machine, or the PCB guy is doing the simulation. Oh, that could be one person doing the whole thing. And what Fusion does is it brings all of that plus a lot more to one single cloud-based program. Things like data management and additive manufacturing and subtractive and management of data, all within a same platform for a relatively affordable price per year. It's that simple. You subscribe to Fusion as a complete program. What you also have the ability to do on top of that, if you need to go a little bit further, is to add on what they call extensions to Fusion. Now, these at the moment come in the form of either consumption-based. So if you have Fusion, you can use a cloud credit to do some machining, or a cloud credit to do some generative design, if it's a one-off. Or if it's something you want to do more regularly, you can subscribe for unlimited access for the entire year for a set price. And actually, at the moment, what's really great at the moment, Autodesk, and it actually ends this week, ends on Friday, is they're actually offering a pretty decent discount on these extensions. So subscribing to these extensions for an entire year for a really affordable price. They've also literally yesterday announced the addition of 2 more extensions, one around simulation and one around advanced design, that we will be presenting to you next year, hopefully. So please stay with us and watch our communication, and our YouTube channel will be, I'm sure, doing a presentation on these additional extensions. So for those of you that already know Man & Machine, you know what we're about and what we offer here. But essentially, the services that we try to deliver is all about you, our customers. We're always trying to make sure that any investment that you make in software or technology can be realized with training and support and deployment help. And our experts, and Cameron, who's going to be presenting the Fusion extension shortly, is going to be one of our engineers that is able to help you to get really what you need from the software. And without further ado, what I'd like to do is to hand over to my colleague Cameron McKenzie, who's run a lot of our webinars on Fusion over the last couple, and he is certainly an expert in all things Fusion. And I'm going to stop sharing my screen and allow Cameron to present Fusion. And I think what Cameron's going to be presenting is a couple of elements around Fusion and the extension. So I'm really excited to see what he has to offer. Over to you, Cameron.
Awesome. Thank you, Simon. Good morning, everybody. Welcome to today's webinar. So yeah, as Simon has said already, today we're just going to be looking at the additive manufacturing environment and the extensions inside of Fusion. So we're going to start off with just a very basic, the fundamental parts of the additive manufacturing process inside of Fusion. So this is what comes as default inside of your subscription to Fusion. So this is without any add-ons, without any extensions. So this is great for any hobbyists or for anybody that kind of wants to do any of the prototyping of parts before obviously going to the full manufacturing process. Or again, if you're a hobbyist or just want to create smaller plastic parts, we've got the ability to print pretty much, or to create setups inside of Fusion for this. So for this example, I've just got this little Man & Machine logo over here that I want to print off using my my printing setup. So I'm in the design workspace at the moment, which is obviously where you create your designs. You can see my timeline down here at the bottom of the creation of this particular part. To go into the manufacturing workspace, it's essentially just a case of switching the workspace up here in the top left. And if you are familiar with Fusion, you'll be familiar with the different workspaces. And we've covered a few of these in previous demonstrations. So if you are curious, feel free to have a look at some of our other ones as well. So for this one, we're going to go straight into the manufacturer workspace. And inside of the manufacturer workspace, We've got a few different types of manufacturing processes, and they're all divided into their individual tabs. So we've got milling, which would be your CAM, or milling and turning, and then we've got an additive tab up at the top as well inside of the manufacturing workspace. Today we're going to be working inside of this additive workspace. So yeah, to get set up, we're going to have to create a setup for our 3D print for our additive process. This is an existing one set up 3 over here, but I'm just going to create a brand new one based on our model. First thing we want to do though is, other than creating a setup, is we could come in and create a manufacturing model. So this is a model that's specific to the manufacturing process, and it therefore doesn't affect your base model. It doesn't affect the design model. You can make any changes really to this manufacturing model. So if I come in here and say create manufacturing model, it'll then take me to the setup of this particular model. Let me just click it again quickly, see why it's not creating a new one. I've got quite a few there. Oh, okay, I am on one in here anyway. So I can come in, you can see we've got a folder on the model browser here on the left, where it has a few various manufacturing models that we can choose from. And these are, every time we click create manufacturing model, it'll create a new one. We can come in and edit any one of these as and where we want. We can come in and change which bodies show. So we can come in and hide certain bodies or remove certain bodies from this manufacturing model. We can also come in and make tweaks to this. So we can come in and edit the manufacturing model as well. And this is where we could add in further chamfers, further fillets. We could come in using our press and pull and make any tweaks that we wanted to hide or suppress certain features of the part itself. And this is really just getting in line with ensuring that it prints off in the way that you want it to print off. So perhaps you were going to use additive manufacturing as your initial process, and then add in second or third stages where you're actually machining the part as well. So this is great for creating those. So for this particular one, I'm just going to turn off a few of the bodies. I think it's pretty much all of them except for the original body one, just so that we're printing the base of this part itself. So you can see we've got this with a little bit of a inset over here for that. In this model, it was just a bit of glass, but anything that might have been inside of that inset over there, because that's essentially all I want to print off in this particular model. Once I've got that manufacturing model set up, I can then create a setup or edit one of the existing setups. And to do so, we can come in right here in the setup panel, select create setup. And inside of your setup is essentially where all of your settings for this, this process will be created or set. So we inside of the setup, we can select the machine. So right at the top of the list, we've got the machine which we can select. And this will take us, if we choose select, into the Fusion library or the Fusion machine library. And this is anything that we have either created within our own local library. So we've got a My Machine section where we can pick machines that we've created locally, or Fusion also has a wide variety of machines that we can choose from different vendors as well. We can filter this list down as well, down to its capabilities. So we're currently in the additive manufacturing, so it's currently filtering down to only the additive machines. And we can also filter down. If I select the Fusion 360 library here, you can see all of the additive machines. We can also filter down based on the different technologies. Now, inside of the base Fusion additive environment, we've got a few of the, as I said earlier, the plastic manufacturing. So we've got FFF, and I think we've also got some SLA, and a few others. But these are the main two categories or the technologies that we have inside of base Fusion. And we can essentially just pick a machine from here. I'm just going to go in and pick a machine. Just try this one here. And you can see if once we select the machine from the list, we've also got an information section here, which will give us the dimensions of the machine, as well as any of the axis information as well. As soon as we select that machine again, which means we want to use this one for our print. It'll give us a bit of a preview of the bed itself, just to make sure that our print can actually fit on there. In this case, we can see this particular one is a bit small. We could obviously change the size of the our part to match the bed, if that was the bed that we were going to be using or the machine we were going to use. But just for this example, I'm just going to come in and choose a different one from the list quickly, something a little bigger, which I believe should be Ultimaker. Yeah, perfect. Yeah, so you can see we've got now a bigger bed that we can use for this. And what we will then need to be able, well, what we will then want to choose is the print settings. So the print settings are based on the machine we've selected. This pretty much rules how your part itself will be printed using the different materials, the different strategies that are available to it. So if we use the select option over here, I can open that up and you can see we can choose between the different materials that are available to us. So we've got ABS, we've got CPE, we've got PLA, and PVA. And each of these have can have different nozzle sizes. These ones don't, but if we had some of the other machines that have different nozzle sizes available to them as well. And you can see we've got different layer heights based on these different strategies, essentially. So we could come in and choose based on the machine, the different strategies that are available for that. So I can come in, select, different settings rather. The setup type is additive by default because we are in the additive tab, but from here we could choose a different operation type if we wanted to. And we can also choose to have the arrangement of our part automatically placed inside of the bed. So with that checked, it will automatically place this part into the bed with the correct arrangement. We can also then choose which model we're going to be using for the print, and this is where those manufacturing models come in really handy. At the moment, because we had manufacturing model 4 selected, it will automatically select that for us, but we could come in here and change to the different manufacturing models as well. And you can see how each of those with their different representations will show up inside there, and it'll automatically select all of the bodies inside of that as well. I'm going to choose manufacturing model 4 because that's the one that we chose and I set up for this at least. And then you can see it's picked up that body. So as soon as I hit OK, it'll then automatically place that inside of the bed. And you can see that it's got our, it's placed that directly right onto the bed. If I look from one of the side views here, you can see it's placed directly on the bed. If you wanted to change the positioning of this, we've got the move, we've got minimize build height, which will then make sure that anything that might be a little tall comes down a little lower to the floor, obviously reducing the amount of time that it takes to print. And we can also select this option here, which places parts on the platform. Using this, we can also then give a bit of a platform clearance. So we can come in, select the body that we want to place on the platform, and we can assign a clearance over here. So if you don't want to print directly onto the bed, you want to have a little bit of support and then print your model, you can come in and add a bit of clearance. In this case, I'm just going to say maybe about 5 mil. If I hit OK, you can see if I go into that right view now again, we've got a little bit of a gap between there, which we can now fill in with some supports. So next buttons over are the print settings selection, which we've already done inside of the setup. You can override those. If we come in here, you can see we've got exactly those same options. We can come in and change those from within here. And then the print setting editor, where we could then make tweaks to each of those settings. So you can see this is that print setting that we've chosen. We could come in here and make any adjustments that we want to this current setup as well. So if you wanted to make any changes to the extruder that it was using, extruder 1 or extruder 2, the layer height, extrusion width, and so on, based on different layers, how many parameters they have. We've got infill as well, the infill angles that are available to it, down to supports and bridging and cooling, and all of those are available in here. And again, these will be different based on the different settings that you have. So if you ever wanted to make any tweaks to the print, you can do them from within here as well. we'll have a look at some of the other options in one of the other examples a little later on as well. The other thing we can change inside here again, especially with the FFF printing strategies, is we can change the infill that's available to us. So at the moment, it's on the gyroid, and we can also just change that either to star, honeycomb, squares, flower. There are quite a few options that are available, and this will change the pattern that's inside. And obviously each of them have different strength advantages based on the different material, based on the different geometry that we have. So you've got a few options here again for playing around. I do enjoy the honeycomb one, so I'm just going to choose that one for this one. And you can see we can choose the infill density. You can also choose the angle for both the sparse and the solid, and a few other options available. And this will then change inside of the print settings as well. So this is just a quicker way of changing those at a quick glance, essentially. As soon as I hit OK here, the last thing I want to do quickly is just add some supports. So obviously this part needs to be attached to the bed itself before it can generate the actual toolpath itself for the printing. So I'm just going to add some supports in here. I'm just going to go for some really basic supports. I'm just going to add these ones in here. You can see we've got some options again: enable support, which extrude it uses, yeah, and a few other options just surrounding the supports themselves. So as soon as I hit OK here, if I expand this off, you should see it will start to generate that. It should do so. Let's try that one more time quickly, just to see if it's doing that for me. Doesn't want to do it on this particular one. I'll do it on the, it's a bit better, better example on the next model. So I'll just change the positioning of this one quickly without any offset, just so it's directly on the bed. Yeah, that's the one. Cool. But yeah, so once we've got those in, you can see we've got our additive toolpath here. I probably should have just generated that, and it would have added the supports in. But if I just right click and select generate, it'll run through the simulation and the creation of that toolpath there, and you can see the progress bar or the progress on the left hand side, and this will take a little while. It obviously just needs to go through the entire part layer by layer and essentially slice it at each layer and add in a toolpath for each of those layers. And you can see now it's managed to get through that pretty quickly as well. All we really need to do from here is select the setup and then choose to actually simulate this. So inside of the actions panel, we can choose simulate additive toolpath. And this will then take us into the simulation environment where we can actually simulate the entire process. So you can see this one's started off with the with a bit more of a solid stripe, just for some of the outer layers, and we can use this arrow that's inside of the browser area itself just to move our simulation further and further up the toolpaths themselves. You can see it has got quite a big jump initially, and that will be just because of the number of layers that we're allowing it to show at once. As soon as we zoom in, it'll increase with smaller increments, and we can show fewer and fewer layers or jump fewer and fewer layers at a time as well. We could also come in here and look at specific layers, or we could bring our timeline right down at the bottom all the way to the beginning, and then play through this, and it'll essentially run through the entire simulation step by step, essentially, and you can see how it will run through the printing of this particular part. We can also speed this up, so it goes right the way through a lot quicker, or we can use the timeline right at the bottom and just move ourselves along to different phases. Oops, that's not there. There we go. And you can see we can drag this all the way along, and it'll show you the height of the layers on the side as well. Also has a few extra different colors, I suppose, for the different representations of the layers. So we've got an outer perimeter marked in red, we've got an inner perimeter marked in green, and then we've got the infill marked in orange. And as you add any further supports or other geometry, the other colors will come up as well. We've got some for supports, we've got some for bridges, and we've got some skirt or brimming on the side, as you can see over there as well. And essentially, once you've got that all set up, and once you're happy with this, I mean, you could always go back. If I hit cancel over here, I could go back into the settings editor and make any tweaks that I wanted to, and then make sure that that's then regenerated, and I can view the process again. I can simulate this again. But essentially, once you're happy with that, you could go straight out either into the post process, where that you can actually publish this script out, either in NC code or directly out of this as well, as an STL model. So you could come and export this directly out. So if we go into our simulation environment and go to post process, it's pretty much the same thing, where we can come out and actually publish this directly off to our 3D printers, essentially. So yeah, that's essentially the process involved in the basic version. I say basic, in the base version of Fusion. So this is out of the box, essentially, that we're able to have this functionality. With the extensions, we've now also got the ability to print, so to use metal printing. So we've got SLM available to us, and SLM is selective laser melting. So we can essentially create metal parts using our 3D printing capabilities inside of Fusion. So using the extensions, we've now got the ability to do that. And to show you this for you, I'm just going to open up this generative design result that we've got from a recent study that we've done. For those of you that have been following along with the series, you'll remember the motorbike that we've been using in previous examples. This is just the brake pedal from that we've decided to take through the generative design process and see what models came out of that. And this is now a result of that. So again, we're just going to use a very similar process to what I used in the previous one, except this one's going to be specific for metal. So we're going to go from the design workspace straight into the manufacturing workspace. And then from here, we've essentially got the ability to use the extension to now use the SLM strategies. So to access this, we'll need to have activated our extensions inside of the extensions window that's available to us. I'll show you the window in a little bit as well. But essentially from inside here, we've got both the Fusion Additive Build extension and the Fusion Additive Simulation extension. I'll show you the Additive Build extension for now, and then in a little while, I'll show you the simulation extension as well and the capabilities of that. So yeah, essentially with the Additive Build extension, we've got the ability to build using the SLM processes, and we've got a few extra bits of functionality that are available to us using this. So again, same process. We're going to go into our setup. This time, I'm not going to create a manufacturing model. I'm just going to go into my setup and create a setup for this particular part. I'm going to choose my machine. And this time in my Fusion 360 library, I'm going to filter out and only show the SLM machines. So this will only show me parts that can print using the SLM technology, essentially. I'm just going to choose a machine from here, this one. From there, and you can see again, we've got the machine dimensions, we've got the part dimensions if needed. In this case, it doesn't show any part dimensions, it just shows the machine bed sizing, essentially. We've also got axis information and all of that. So the same information is available to us from here. If I choose this one and select that, in the print settings, again, we've got different settings that are available that are specific to this machine. So if I come in here, you can see the different materials that we can print with. So we've got some titanium, we've got some Inconel, we've got some cobalt, and we've got some aluminium. For this particular one, I just want to choose the titanium. And we're going to use the 30 micron. Again, we've got some information on the side here as to the build rate, the material, the layer height, and so on. So I'm just going to select that, and you can see it changes inside of this the setup manager, essentially. For this particular one, I won't use the automatic placement. I'll arrange this myself. So I'm going to turn this off. And again, it's just chosen that body because there is only one body in here. So very, very quickly, we've just chosen the machine, we've chosen the print settings, and I've unchecked automatic placement because I'm going to place this myself. So I'll just hit OK on there. It will highlight red because it can't currently print this because, again, it's not on the bed. So I'm just going to change the placement of this using the move tool. I'm going to select the component that I want to move, and just looking at it from the side, I'm just going to eyeball its positioning initially. And I'm going to just rotate that around because I want it to print the other way around, and maybe change its positioning a little more and put it up slightly. I'm just going to zoom in just to get a bit finer placement on that. Maybe just a tweak to the side. All I want to do next is just rotate this around a little bit more so it fits a bit better into the bed itself. It is a little too close on the pedal over there to the base. I'm just going to pop that up a little bit more, maybe drop it down. Yeah, perfect. So once I hit OK on there, it's now placed that on the bed itself. And again, you can see obviously we don't have any supports on this one. So this is where I'll show you how the supports themselves work. So again, we've got the print settings, which we've had a look at. If I go into the print setting editor quickly here, what you'll see is we've got a few different options again. So because this is a different machine, which has its own print settings, we've got a few different options that are available again in here, where we can give the machine an identifier, we can add some descriptions, add comments, and make any adjustments to any of these settings as well. But we've also got the ability of changing the strategy. So we've got a default factory build strategy that we can use. If I just select this and it catches up with me, there we go, cool. From in here, again, we've got the option of changing a few settings in here. So inside of the volume, we've got the ability of changing how it hatches and how it fills contours, how many contours we'd like this particular strategy to use, the hatching, how many layers it needs to hatch. But we've also got different types. So this is the pattern type, the fill pattern type, essentially. So we've got chess, we've got stripe, we've got hexagon, and a few other options available, again, that we can change inside. Yes, you can customize this really as much as you can, or as much as you need to within the limitations of your machines as well. We could also have multiple strategies. So if you wanted certain parts to use one strategy and other parts to use a different strategy, we could come in and duplicate these and assign individual strategies to individual parts as well. So that's inside of the print settings editor. So the build strategy here, if you had multiple bodies, we could choose a different strategy for each individual target body, essentially inside of this this process. We've only got the one, so we're only going to use the one strategy, but to access that, you could do so inside here. As for the supports, we've got the ability of using both volume supports and bar supports. The volume supports will essentially just create a lot of volume underneath the part, and will basically be a pedestal that it sits on top of, and anything we select inside of the part itself. So we could select individual surfaces under the part itself, and it'll create a volume underneath there that supports that. For this particular one, I'm going to select the entire part, and now it will then create supports underneath the entire part for us. Again, we can come in and make tweaks to the supports themselves. So we've got the ability of choosing the supported area. Therefore, I've chosen the whole part. We can add some advanced area filters. We can set the distance to the support as well. We can change the fill type. So whether it be a structured support or whether it be a hollow support. We've got a few options inside of the volume as well, whether it have wired walls, punched plates, or completely solid. We can ask it to, or we can request that it thickens up the structures or adds fin structures. So very customizable with the supports inside of this simulation as well. The last option in here, I'll just skip over the raster and contour, is the connections. And this is where we can set how it connects to the part itself. So if I just hover over here, you can see the different types. So we've got breaking point, we've got offsetted breaking point, and we've got strip. If I hover over those again, you can see we've got breaking point, which doesn't show as, or which doesn't connect as much to the actual part. We've got offsetted, which has a bit of a connection to it that we could then machine off afterwards or cut off afterwards. And then we've got a full connection there, which is the strip. And that's fully connected to it, which has a few different ways of breaking off. So we could have that to the top connection point, we can have that to the bottom connection point, and the platform connection point. We can choose any one of those options, or we could customize that as well. Awesome. So as soon as I hit OK on that, sorry, quite a lot to cover inside of the volume support. If I hit OK on there, you'll see it then generates the support inside here. It's just running through its calculations for that. I'm not going to click anywhere just so that I don't anger Fusion. This is usually obviously dependent on the curvature of your part and how simple your part is. Usually takes a few seconds to a few minutes. I think in previous tests of this particular model, it took about just over a minute or so to generate the entire support. But essentially what this is now going to do is in the background, there you go, quite a few seconds for that one actually, is analyze the geometry of your part, analyze the bed of the machine itself, and then just connect those points with support. So you can see how it's taken to those curves really well. So we can see it all pretty much all the way around, except for maybe this little gap over here where it didn't need that support because the part itself would have supported itself during the printing phase. Although maybe over here it would need some supports a bit later on. So you could come in and add some on top of that, or as you'll see later on, we'll run a simulation and see which areas may need a bit more support. So we'll hold that thought for a little while, but essentially it's come in and placed supports directly below the entire part. And all that's really required now, we've got the part, we've got the supports, is to generate the toolpath. So again, same process. If we right click on here and select generate, or we could select generate from the actions panel, this will then go back and begin to generate a toolpath for the supports and for the part itself. And again, this part will take a little longer than creating the supports themselves, as obviously Fusion is needing to calculate where the various toolpaths need to go and how it needs to handle each layer individually. So it essentially slices every single layer incrementally and will generate a toolpath for each of those layers. Just a bit of a heads up for the next phase or for the next demonstration section, we have just recorded a video of the process again, just to speed up this, because obviously we could spend quite a bit of time sitting around waiting for these progress bars to load. So for the next section, I've got a bit of a video just to show you how the other extension works. And the only reason we've really recorded that is just to speed up these loading times, because it does take a bit longer. Obviously, with the more detail that there is, you can see how much curvature there is on this particular part, and to be able to get Fusion to calculate that every time, it will obviously take a little longer. I think, if I remember correctly, it took about 12 minutes or so for the entire process, and we've managed to reduce that to about a 5-minute video. But yeah, you can see obviously as it's running through that in the background, it's giving us a bit of a progress bar over there, and I think it does tend to slow down a bit at about 75 and should pick up from here as it's kind of running through the last few iterations of that.
Just while we're waiting for that to finish up, Cameron, we had a question come through from Mark, so I might just ask that to you live, if that's okay.
Yeah, that's cool.
So with regards to the supports that you've placed here, naturally you've just lifted the part up and it's just taken the bottom of the solid and down. But what if you had overhang towards the top of the component and you needed to add a manual support to an individual face or an individual section of that component? Is that possible inside of this add-on with Fusion?
Yeah, certainly. So where I selected the entire body earlier, I won't do it just yet. I can show you in a bit once this is calculated this completely. But inside of the volume support, you could select individual faces. So you can see as I hover over the different faces here, you can select individual areas of the part itself that you want to support, and it'll only add the support to that individual face. So let's see if it'll allow me to do it now. It should be fine with it. You can see here in the supported targets, if I hover over and select individual faces from here, let's go for one that isn't supported at the moment, probably one of these here on the side. It'll add that little face over there to the selection. And as soon as I hit OK, it'll generate a support for that. So essentially you can come in and tweak those as well.
Perfect. Thank you, Cameron.
Cool. Yes, it's managed to generate that toolpath. So we're just going to jump straight into the simulation of that. So you can see again, same process in the actions panel. We've got the simulate additive toolpath. I'm just going to select that. And what you'll see is very much the same setup as before. Just with the SLM models, we've only got two types of material, I suppose, or two different types of strategies, I suppose, that Fusion uses. So we've got the parts and we've got the supports, parts being in orange, supports being in the bluish color there. What we do have though inside here is the ability to show or set how many layers show or how many layers it jumps each time. So we can only, if we wanted to, by default, only show every 100th layer. I do prefer using every 5th layer instead. It just gives us a bit more accuracy. So we can filter that down as well. Sorry, my machine is slowing down a little bit now. But if I come in and again, using this arrow, I can bring my printing procedure right the way through, and you can see how it handles each of these layers. If I get a little closer in, you can see the different printing strategies that are used in this. So we've got our supports that are being printed there, as well as the infill of the part itself. I could come in and hit play as well, and it'll then play through, and you can see how it's running through printing each of those layers. If I speed this up a bit, you can see how it goes and tackles each area individually and pretty much runs through the entire process, then jumps up a layer and does it again. So yeah, you've got various ways of viewing this. And again, I can come in and use this arrow and change. If I pause, it'll be better. And I can come in and move this arrow about just to view individual sections and see how it handles different parts of the build itself. As you can see, as it comes further to, or closer to the top there, it's got a lot less to then print off. We can come all the way down to the point at which it's printing the supports as well, and view those directly from there. If I, sorry, just go back into that, I can skip all the way to the end of the toolpath as well and just see how the entire thing will have printed, and where it sees that it'll be finishing that final process. Essentially, we've got the volume of the support as well. We've got the current height and how many layers are included in this particular print. So you've got a few few bits of extra information available to you inside of this view. But yeah, so that's essentially the SLM or the additive build extension. So we've got the ability now to print metal objects as well, using the SLM strategies, as opposed to the default or base Fusion only printing plastic parts as well. As I said earlier, I'm just going to open up the video quickly of our additive simulation extension, and inside of this, I'll show you a bit of where we get the extensions and actually activate the extensions as well. I'll talk over this. We didn't record it with any sound, so if you're happy for me to, I'll just carry on talking on top of this and just show you, the different processes involved. So essentially, same part as you can see over here. We just needed to add or regenerate the supports for that particular one. But what you can see is just by going up in the top right, we can select the extensions manager, which I showed you earlier. And opening that, we've got a few extensions that we can choose between. So we've got the additive build that we can choose, and we've got the additive simulation that we can choose inside of that list. And it's just a case of then purchasing those from within Fusion itself. The additive build obviously gives you what we've just had a look at, and the additive simulation will now allow us to simulate the print of our particular objects, and this will allow us to then have a look at different areas that may require either adjustments. So as you're printing, obviously you've got certain areas that may need a bit more support or may have a bit of deformation. And this additive simulation will essentially run through a simulation process to ensure that those areas are highlighted and considered, and we can then export a compensated model that will ensure that those areas are then printed to the design intent, essentially. So in this case, we've just added those supports here. To activate the simulation, we need to go through a checklist up at the top in the process simulation. And inside of that, it just goes through various checkpoints where we can choose the printing settings. So we could come in and choose the different settings in there, which I've shown you already. It just wants to make sure that we've got those chosen. We can then choose the accuracy of the solve itself. So we can either choose a very accurate or a very fast one. And the only real change that it makes there is the layers per element. So to have it go through very quickly, we can bump it up to 25, or we can then decrease the layers of that. We can see we've got the coursing generations as well that we can change from within there. The other condition is that the platform has contact, or the part has contact with the platform, which it does in this case through the supports. And then the last thing that it needs is to create a mesh of the model itself. And this is one of the processes that can take a little while. This is a bit quicker than the final solve, but you can see it does take a little while. We've had to speed this up. I think in this case, it took about 2 minutes or so. And once it's done that, it then creates this meshed version of our part and the supports themselves. And you can see if we zoom right into here, it almost creates like a pixelated version essentially of the model itself. And this is just the different areas that it would then use to, or the different blocks that it would use to calculate any deformation at the different layers of the generation process. So you can see in this particular one, we've got the blue for the dark blue for the support and the lighter blue for the part itself. All we then need to do is go back into the process simulation panel and choose to actually solve this study. So we can choose solve from that menu. And again, it's just going to run through in the background. I think this process probably took about 8 minutes or so for this particular model. So we've just skipped through most of that. And essentially, once we've generated this, it's going to give us a simulation view. And if any of you have used FEA, you can see it's very similar to that, where it gives us a maximum and a minimum deformation. So maximum at this particular point was 0.027 millimeters. But you'll see as we hit play now, it's going to go through layer by layer and show us at each point which area had the most deformation. And you can see again in that bottom right corner for now has the most, but as we continue through the rest of the simulation, the deformation changes from one side to the other. So now it's at this this front left corner-ish of the part itself. And at the moment, it's sitting at about 1.5 millimeters. So quite a substantial amount of deformation on this particular model. Again, we could come in and add extra supports. So you can see those areas that struggle right at the beginning. If we added some more supports in there, we could come in later on and run the simulation again, just to see if that's added anything to it or added a bit more strength or less deformation to it. or we could come in and again add some supports onto the other side if required. We've also got a few other options we can use to view this particular model. And we can also change what is represented as the maximum and the minimum. So at the moment, the maximum is the highest number, but we could drop that down to 1 millimeter or push that back up to 2 millimeters if we needed to. And that would essentially just show in red which areas exceed 1 millimeter or which areas exceed 2 millimeters of deformation at that particular point. I think, again, we're just going to run through the simulation one more time, I believe. Sorry, and this is just the point at which we could export the compensated model. So if I just go back 10 seconds quickly, up at the top right in the actions panel, we've got the ability to export a compensated STL. So this will essentially take the findings of this result and export a compensated model of this part. And we could then push that out to our printer as well. And then it'll obviously take into consideration those. We've also got the ability to print off or save out the results of this particular study as well. So if you ever needed to have that done, you've got the ability to do that as well. So we're just going to have a look one last time quickly at just the entire process or the entire simulation. And you can see at each of the phases, the maximum and minimum areas of the deformation from there. Awesome. But yeah, I think that's pretty much all we were really needing to cover today. So I think for now, I'll hand back to Simon, unless there are any further questions. I'll just show you this really nice other version of the same pedal that we've been able to get from Generative Design.
Very nice, Cameron. Thank you very much. That was a really great presentation, actually. I really love, because I know that with 3D printing in metal, deformation is a big challenge. And being able to compensate for that and export a model that will come out correct at the end is wonderful. So thank you very much for your presentation. And also just the basic stuff in standard Fusion. There's a lot of customers that are on this presentation today that are using the product design and manufacturing collection. So they'll be using Inventor and AutoCAD and 3ds Max and everything that you get in the collection. But they also have Fusion. And they have Fusion in the box, and they might have a maker bot or something in the corner. Well, Fusion has the ability to do the slicing as standard, and when they want to go to the next level of additive and 3D printing in metal, then they have the option of adding the extension. So wonderful. There was a question while we were talking, just more on it wasn't a technical question, it was more on the commercial side of things, which is that the customer had a product design collection that renews in, I think it was June or July next year, and they were asking about the extension and whether they could, instead of buying a whole year of the extension, whether they could co-terminate it to their existing contract. And of course you can, as with all Autodesk software, if you already have a contract and you need to add or buy new software, you can co-terminate that to your existing contract on a month-by-month basis. So it's relatively simple. But I said to the chap on the chat that it's worth thinking about that this week because of the 30% discount. So definitely worth getting in touch. Hopefully a lot of you have our contact details already. Of course, we offer training and support, and Cameron can be with you to do some training, whether that's bespoke or something out of the box, of course. But thank you very much for your time, everyone, today. Unless there's any other questions, I think we'll wrap up for today, and I'm sure you'll be doing another presentation probably in the new year now. This might be the last one before Christmas, so I will say it. Unfortunately, I will say have a great Christmas, and I'll see you in the new year. But thank you, Cameron. Thank you, everyone, for joining us, and have a good day.